Good day, grade 11. So, how are you today? So, for now, we're going to discuss about the Z-score or the standard scores. The standard score or the Z-score measures how many standard deviation a given value of x is above or below the mean. The Z-scores are useful in comparing observed values. A positive Z-score indicates that the score or the observed values is above the mean, whereas the negative Z-scores indicates below the mean. It is also said that the Z-score is a measure of relative standing. It is a standard deviation value. It is the distance between a given value x and the mean. It is called as standard scores. It is calculated by subtracting the mean and by dividing the specific mean measurement x and then dividing the result by the standard deviation. The Z-score indicates x either within the sample or within a population. To determine the Z-score, we need to use the formula. So if we are going to find for the population, so you have the formula, Z-score or the standard score is equals into the given measurement minus the population mean all over or divided by the population standard deviation. While if you are going to find for the Z-score, the standard score, for example, so you have the standard score is equals into the given measurement minus our sample mean divided by the sample standard deviation. There are situations when the data need to be converted into standard form to be meaningful. This is where the use of the Z is practical. The Z-score serves this function. We have learned that any population has fixed parameter values. The Z formula matches the Z values one-to-one with the X values. This implies that for every X value, there corresponds a Z value. And for every Z value, there corresponds one X value. Now, the Z values are matched with the specific areas under the normal curve in a normal distribution table. And these areas depict probability. So, it is possible for us to find the percentage or proportion associated with X. Okay, class, let us have some examples in finding the Z-score. For example, you're given X or the given measurement is equals into 90. So, the sample standard deviation is 10. And of course, our sample mean is equals into 80. So, using our formula in finding for the Z-score, so let us have the solution for our example number 1. So, in finding that, so we must use the formula Z-score is equals into X minus our sample mean all over our sample standard deviation. So, you have here now, as our given, you are going to have 90 minus 80 to be divided by 10. So, we all know that 90 minus 80 is equals into 10 divided by 10. So, we have 1. So, therefore, our Z-score is equals into 1. In that case, so that is within a sample. And of course, our given is above the mean. Another example. So, for our example number 2, so Z-score is equals, so use the formula, given measurement minus the population mean to be divided by the population standard deviation. Just substitute for the given. So, you have 30 minus, so our mean is 42 to be divided by the standard deviation 5. So, you have 30 minus 42 and that is negative 12 divided by 5. And we all know that is equivalent into negative 2.4. So, that is within the population. And of course, our Z-scores or the standard score is below our mean because as you notice, we have here a negative answer. Okay, class. So, let us have some examples in finding for the Z-score in a population. Okay, for example, your problem is, in a population of mathematics 4, the mean is equals into 68 and the standard deviation is equals into 5. We're going to find for the Z value that corresponds to a score x is equals into 73. So what are you going to do first? So the first step that you're going to do is you're going to use the computing formula to find for the Z-score of a population data. So let us use, say, is equals into the given measurement minus the mean all over our given population standard deviation. Second step, you're going to check the given values. Since these are the population values, the z-scores locates x within a population. So let us now substitute for the third step, substitute the given values in the computing formula. So our given measurement is equals to 73 minus our given population mean is equals to 68. All over or divide this by our given standard deviation or population standard deviation, which is 5. So let us subtract 73 minus 68, and that is equivalent into 5. Divide this by 5. And you all know that 5 divided by 5, and that is equals into 1. So thus, plus, of course, we all know that the raw score, so the raw score, 73 corresponds to a z value of 1. Okay, class, let us have another example in finding for the z-score. On a final examination in mathematics, the mean was 75 and the standard deviation was 12. Determine the standard score of a student who received a score of 60, assuming that the scores are normally distributed. In this given example, so we all know that we are going to use it as a sample. So like in our first example, you need to follow the steps. So first step, you're going to use the computing formula for finding the z-scores of a sample data. So you have here z-score or the standard score is equals in the given measurement minus the sample mean all over our sample standard deviation. And then for the second step, so you need to check for the given in our problem. And then for the third step, we need to substitute. So our given measurement is equals into 60 minus our given sample mean is equals into 75. All over our sample standard deviation is equals into 12. Okay? 60 minus 75, we all know that is negative 15. Divide this by positive 12. And negative 15 divided by positive 12 is equals into negative 1.25. Okay, class. So thus, the raw score of 60 corresponds to a z value of negative 1.20. So, in that case, it indicates that the 60 is 1.25 standard deviations below the mean. Okay, class, so that is how you're going to find for the z-scores or the standard score of a normal distribution. So I hope you had new learning today. So if you have questions, do not hesitate to ask your teachers. Again, thank you for listening and Laus Deo. Keep smiling!